Hi folks, Harry Frank from Red Giant here. In this tutorial, we'll be talking about the physics section in Trapcode Particular. We've got a lot of material to cover here, so I'm just going to jump right into it. The physics section in Trapcode Particular at the very top has this selector that allows us to select two different physics models. And we'll be learning about both of these, but in this tutorial, we'll be talking about the air physics model. Now notice as I select either of these that the air section or bounce section grays out according to which one I select. Currently, Particular doesn't have the ability to select and use both of these models at the same time. The short explanation for this, because it's a very common feature request, is that at its core, it's not a particle simulator like a more complex particle system like you'd find in, let's say, Houdini or Fusion. If I jump around in time, you'll notice that Particular will instantaneously render a frame without having to calculate the frames in between. At any given point, it knows where a particle is going to be based on what is going on within the plugin. With that said, running air and bounce simultaneously breaks this ability to instantaneously render without having to cache frames in between and greatly slowing down Particular. So that's the short answer as to why currently air and bounce are not available at the same time, but know that it is a common feature request. Common to both sections, air and bounce, are two parameters. One is the gravity control. The other is physics time factor. Let's cover the gravity control first. I'll hop into the designer here and go to my physics section and select the gravity block. In the gravity block, this is actually where we see both physics time factor and gravity. Now, gravity is simply a force that accelerates our particles downward if the value is positive. If I set the gravity to a negative value, the particles will accelerate upward. The part that I really want you to understand here is that gravity is a force of acceleration. It's not a constant velocity. It doesn't just have your particles move downward or upward. The effect of gravity starts at 0 and increases over the lifespan of the particle. You can see this if I go into my velocity and set this velocity to 0. And I'll also make a slightly larger emitter size here. I'll set this to perhaps 2000 and 0, 0, and Y and Z. Let me turn up the particle count just so we can see a lot more of these and move the emitter up a little bit. So up here where the particles are born, the particles are a lot closer together. And over their lifespan, they accelerate downward. So when you use gravity, it really is going to depend on what you want the particles to do. Do you want the effect of gravity that causes the velocity to increase over time, or are you looking for something that is more of a constant velocity of the emitter, or we have an option of using wind, which I'll cover in just a minute. Now, totally unrelated to gravity, but actually in the gravity block, because, well, these are the only two parameters that will globally affect the other settings, is this thing called physics time factor. I'll jump back into the After Effects interface, and I'm going to create a camera here and set up just a very basic explosion setup to demonstrate how physics time factor works. Now, the short story is that physics time factor is essentially a global time control for how time flows within Particular. A setting of 1 means that there is a one-to-one relationship between the flow of time in Particular and the flow of time in your composition. If I turn this up to 2, the velocities, the acceleration due to gravity, all that kind of stuff, it will all double and essentially run twice as fast. Now, to demonstrate a quick example of how this is useful and what some ramifications are of using physics time factor, let me set up a quick explosion here. I'll go into the emitter behavior, set this to explode, and set the particles per second to 10,000. So if I rewind to the beginning and hit play, we'll see that we have a very quick burst of particles that expand outward. So let's say we wanted to create some sort of freeze frame effect where we freeze right in the middle of the explosion. Physics time factor is perfect for this because we can control time. Now, it's currently set to 2, so it's actually running double the speed. I think it's totally fine to use physics time factor to actually kind of boost the overall feeling of your particles. It will boost the particle count, the velocity, all that kind of stuff. So in an explosion, don't be afraid to reach for that physics time factor and turn it up. So let's say I set this to 3. So we'll run this for a few frames, and then we will quickly bring this down to 0. And I might need to fine-tune my timing here just a little bit. In fact, maybe I'll set this to a slightly lower value just so that it hasn't progressed so far. Okay, so we have a quick explosion, and we probably should have this ease into a stop. I'll adjust the speed curve of that a little bit. There. So we have an explosion that's moving very quickly, and then we are freezing time to have these particles freeze in place. I'm going to do a little bit of a camera move here. I'll create a null that is 3D and parent the camera to the null and do just a little bit of a rotation move on this, because this is going to illustrate an interesting point that happens with physics time factor. The overall concept of physics time factor is pretty easy to understand until you start to wonder about things like, how does it affect motion blur? So this is why I want to set up a little bit of a camera move. We're going to see 2 different types of motion blur that are resulting from our setup here. So I just did a basic camera move here. I'll also hit F9 just to ease those values a little bit. So to summarize, we have a quick explosion of a bunch of particles that freeze in time. It sits there for a frame or 2, and then our camera pans around. Now, I haven't spoken about motion blur that much with Particular, but just know that when you enable motion blur for your composition and you enable motion blur for Particular, you should see some sort of motion blur. In fact, if I go right here in the middle of the explosion, because remember, these particles have a velocity of 3,000 pixels per second, they're moving pretty fast, so we should definitely see some motion blur. Now, at this point in time where they freeze, technically, at that moment in time, they still have a sort of frozen velocity in time, but we're not seeing any motion blur because, according to Particular, they're not moving, so there's no motion blur. However, when the camera moves around, in fact, if I drag this set of keyframes a little closer together, just to make this more pronounced, we see a bit more motion blur going on. So let's say you actually want it to freeze in place and have the look of these particles still being motion blurred in space. I'm going to jump down to a different section here, which is the rendering section. And inside there, there's a motion blur. And at the very bottom, there's kind of this obscure setting called disregard, which a lot of people probably haven't touched. In here, this actually relates to physics time factor. We can tell it to disregard the physics time factor. So if I select that, at this time where they freeze, motion blur is going to disregard the fact that we've set the physics time factor to 0, and it will retain that motion blur even after they freeze in space. This could be pretty cool if this is the overall look that you're going for. Currently, we are only disregarding the physics time factor, so as my camera moves around, we will have an added motion blur of the camera moving. We also have the ability to say, okay, disregard the camera motion, so that we will still have motion blur due to the movement of the particles, but not the added motion blur from the camera movement. Or we could say disregard the camera motion and physics time factor, and this will render motion blur for only the movement of the particles, disregarding the camera motion. Okay, so let's dive into the air physics controls. I'm going to delete my camera information, so I'm not pulling that into the designer. And let's go to the designer and just make sure that we've reset everything. There we go. Now we're back to our default settings, and we're working with the physics section, physics model, air. I'll start with the controls that I think you'll be using most often, and then we'll go in and fill in the details toward the end. Wind is something that I use all the time, and in fact, I've already shown a few different examples. Wind is pretty straightforward. It is a force that will move our particles in the X, Y, or Z axis. We don't have an angle control, but we have a positive or negative value available for X, Y, and Z. This is definitely useful for creating sort of dust or snow effects. In fact, if I double click on my box emitter here, I load in a box and we make this box really big. I use wind a lot as an easy way to push all of my particles in one general direction, even if I'm using a uniform emitter. Uniform emitters, remember, will emit particles in any direction, positive, negative, in X, Y, and Z. And this adds a little bit of randomness. This is just fine. If I set this to a directional emitter, you'll notice that the particle movement becomes a lot more plain. They're all kind of moving in a single direction. Whereas when I work with a uniform emitter, it adds a bit more randomness. So that's wind. Wind is pretty straightforward. Another one that I use all the time is the turbulence field. Turbulence field is essentially a fractal field that exists in all three dimensions. Now, to understand the turbulence field, I find it very useful to understand exactly what fractal noise is. Now, this is a bit of a simplification, but the idea of fractal noise is that we start with a base layer of noise that's really large like this. And all this is a solid with a noise effect on it. And I've scaled the noise up 8,000%, so pretty big. So we have very blocky areas of dark and light. Now, to this, I'm going to add an identical layer of noise. And the only difference between the two is that this layer of noise is scaled by half, and the opacity is diminished by half. Next, I'll add another layer that is again scaled by half from the previous layer, and is also diminished in its opacity by half from the previous layer. And if I keep doing this over and over, I will end up with something that looks like fractal noise. This is really what fractal noise is. We're adding layers of the same noise with decreasing scale and decreasing opacity. Now, in terms of fractal noise terminology, the number of layers that I have here that make up the fractal noise is referred to as the complexity. If you go to any fractal noise generator, like the one here in After Effects, you'll see that there is a complexity setting right there, which defaults to 6. Now, the reason I explain this is because Particular uses very similar concepts. That turbulence field is essentially a field like this, but exists more in three-dimensional space. You can think of the dark areas as negative values and the lighter areas as more positive values. And we can use these values to push points in space around. So let's jump back over to Particular, and I'll set up a basic emitter here that will allow us to show exactly how this fractal field affects our particles. I'll set up another box emitter, but this time I'll make it very tall. So I'll go into X, set this to 0, and Z, set this to 0, and turn the emitter size up in Y. And let's move this over to the left. And I can zero out the motion by going to velocity. There's also a preset in here actually called zero motion, specifically for that use. So I'm going to add a little bit of wind to push these particles to the right. And I'm going to add a lot more particles in here. I'm going to maybe make about 10,000. Now, a lot of these particles are going to start blending together. So to see this blend really nicely, we're going to change the color of the particles to blue, and I'll also set the blend mode to screen. So the particles are just randomly generating on this line, and the wind is pushing them to the right. Let me go to the physics section under turbulence. And first, I'm going to use this effect position. So we'll take that three-dimensional fractal field, and the negative values will push the particles in one direction. Positive values of the fractal field will push the particles in a different direction. And what this will do, if I turn this up, we'll give it more of this organic movement. You notice we have these areas that are compressed together, or pushed together, and these areas that are more sparse. So these are the sort of darker and lighter areas of the fractal noise, or negative and positive values. You'll notice over here that the effect of the fractal field is not affecting the particles immediately. This is what the fade in time is right here. If I turn this down to 0, they will be affected immediately. If I set this to a higher value, it will take longer for the fractal field to take effect. And we can also have this either be a smooth transition or a linear transition. Generally, I just leave this to smooth. Now, the overall fractal field controls here that control the look of the turbulence field aren't something that you're going to be reaching for day to day. If you want to change the look of the fractal field, I think the most common one you'll probably be reaching for is the scale. This is the overall scale of the fractal field. Lower values make the fractal field bigger. So it's more of like a density control. If I turn this up, it makes the fractal field a lot more dense. The complexity is how many layers of noise are being used to calculate the turbulence field. And a higher value does take more processing power. So always have a reason for turning that up. It will be difficult to see the effects of anything above 3 unless you're using a very detailed look. Like if I turn the particle size down to, let's say, 2, and I turn this particle count even higher to get a more dense feeling. As I go from 2 to 3, you can definitely see more detail being added to those condensed areas where the particles are pushed together. But as we get above 3 or 4, it starts to really not have much of an effect. Now, the octave multiplier and octave scale, I know for many, are a bit of a mystery as to what these are actually doing. Remember when I described the fractal noise that we had a relationship from one layer to the next. We had the base layer of noise, and then each layer that was added was scaled by half, and the opacity, if I show the opacity was diminished by half, from 100 to 50 to 25, 12, etc. The overall blending from one layer to the next is the octave multiplier. The overall scale relationship from one layer to another is the octave scale. So what does this mean for you? Well, as I change the octave multiplier, we'll see a greater effect of those smaller layers of noise. So let's say I turn this complexity up a little bit to 5, and we don't see much of a change. If I turn the octave multiplier up, we'll see a greater effect of those smaller areas of the noise on the particles. If I turn this down, our emphasis becomes more on the base layer of noise. The octave scale is how each layer of noise is scaled from one layer to the next. So if I turn this octave multiplier up, let's say I set this to 2, we can see those small layers of noise coming through quite clearly. If I turn down the octave multiplier scale, we'll see that the more complex layers of noise are actually getting a lot smaller. Now, again, these aren't things that I reach for day in, day out. These are very detailed controls over your turbulence field. Mostly what I reach for is something like the fractal field scale. I definitely reach for the effect position control because this looks really, really cool. I don't reach as much for the effect size, but it is something that can look quite interesting. Beyond that, we just have things that control the overall timing or movement of the fractal field. So right now, the fractal field is actually changing over time. Obviously, it's moving with the wind. And I'm going to jump down here to this move with wind and set this to 0. So now our fractal field is frozen in place and the particles are moving through it. If I turn the evolution speed up, you can see that this is evolving over time, which I think is a very natural way for turbulence to behave. You can manually offset the evolution here using the evolution offset in time, and then you can offset the effect of the turbulence field in XYZ space using the XYZ offset. I'd like to make a quick demonstration of the effect that turbulence can have on even the most simple of designs. So let's say I'm working with my particles here and I have some very basic settings where my particle is scaling out over time, and I've got maybe 500 of these emitting. And I'll change the color to something just a little bit more interesting and have the particles blend using a add blend mode. In fact, I'll brighten this color up just a little bit. Now, turbulence can have a huge impact on the look of a very basic design like this. So when I go to the physics section under effect size or effect position, it gives a much more organic kind of feel, both when the emitter is sitting still, as well as when the emitter is moving and particles are trailing behind it. I would say that I use turbulence field on just about every design that I make. Now, there's a few other things that we haven't covered in the physics section, such as error resistance and spin amplitude and frequency, and we'll combine those into a much more practical example in the next lesson. My name's Harry Frank for Red Giant. We'll see you next time.